Sex determination. In humans and other animals, as well as some plants, there is a chromosomal basis of sex determination. An organism's sex is an inherited phenotypic character determined by the presence or absence of certain chromosomes. There are two chromosomal sex determination systems, XY and ZW. In the case of these Drosophila flies, the female, on the left, has two X chromosomes, and the male, on the right, just has one X chromosome and one Y chromosome. So this Y chromosome is what makes the male different from the female. Sex determination in various species. For honeybees, the females have two X chromosomes. In males, there's just one Y. For humans, females have an X and an X, males have an X and a Y, and then there's the monosomy female, which just has one X chromosome for Turner syndrome, and XXY for Klinefelters. Even though this individual has two X's, there will still be a male pattern in development because of this Y chromosome. Chickens use the ZW system, so a female is ZW and a male is ZZ, which is the opposite of the humans in the XY system because in this case, the male has two of the same chromosome, versus in humans, the female has two of the same. For Drosophila flies, it's a little unique because the females are XX, the fertile females are XXY, versus that would be Klinefelter's male for humans, and a single X is sterile, and then a female is X and Y, which would normally be a male in humans. Sex-linked genes. The sex chromosomes have genes for many characteristics unrelated to sex. A gene located on either sex chromosome is called a sex-linked gene. Sex-linked genes follow specific patterns of inheritance. Many sex-linked disorders are located on the X chromosome. Typically, these disorders are inherited through the mother as she gives an X chromosome to any child she has. Sex-linked disorders show up in males more often than females because they only have one copy of that X chromosome. So if it's X-linked recessive, then any male who's XY and carries that recessive allele will have that disorder, versus a female who is XX may receive the X-linked recessive allele from her mother, but still have a good X chromosome from their father. X-linked disorders. Some disorders caused by recessive alleles on X chromosomes in humans include color blindness, Duchenne muscular dystrophy, hemophilia, and male pattern baldness. Because males only have one X chromosome, these conditions are much more common in the males than in the females. And when we write these alleles out, what we do is we write the sex chromosome, X or Y, and the allele for the sex-linked gene we put up there as a superscript. So in the case of the female, we have X big H and X little h. In this case, it's for hemophilia, so little h is the allele for the hemophilia gene.